Like every sector in the new digital world, the telecoms industry is undergoing significant transformation. The demand for 5G technology is growing, paving the way to richer mobile experiences. There has also been an unprecedented rise in demand for new network services thanks to substantial growth in digital environment that requires more agility, capacity and flexibility. Already on the rise, the demand for mobile voice, data and apps is growing even faster amidst the COVID-19 crisis. Vendors face unprecedented demand for mobile data and video streaming services, driven by distance working, mobile entertainment and remote education. Telecoms towers are essential enablers of the industry, carrying the antennas and dishes required for communications. The need to develop larger, denser and more efficient networks drives the demand for increased antenna space on towers in the right locations and at optimal heights. In many locations, vendors are expected to roll out new 5G while still maintaining access to older generation technologies. This further drives the demand for antenna space on towers. Being high structures, telecoms towers are subject to wind loading. Tower structures are designed to withstand code-specified wind loads. The design of the wind force resisting system includes foundations, structural members, components and cladding, all aimed at avoiding fatigue, shear, sliding, overturning and uplift actions. Each tower structure is designed to carry a number of square meters of antennas and equipment at specified heights. When the designed capacity is exceeded by adding more or larger antennas to a tower than it was designed for, the tower becomes overloaded and at risk of overturning. The capacity of a tower is determined by considering the designed load capacity of the tower and the wind loading caused by the antennas and equipment mounted on the tower. The surface area and shape of each antenna and equipment mounted on the tower determines its contribution to wind loading. By using well-known drag tables, the resistance or drag of each new object added to a tower can be calculated by structural engineers. As more antennas and equipment are added to a tower, the design-specified capacity of the tower is soon exceeded. Overloading of towers are common. A very high percentage of towers in the developing world is overstressed. This presents significant risk to the owner and operator from regulatory, safety and legal compliance perspectives. Consider this typical 49-meter tower. With the antenna and equipment load as shown, the tower is 151% overstressed. How can this overstressed situation be resolved? Reduce tower load by removing antennas. Load reduction has a negative impact on revenue and is not feasible. Upgrade the tower structure. Upgrades to tower structures and foundations is costly, time-consuming, and are often repeated year after year as demand grows. Add a tower shroud? The latest circular tower shrouds could reduce wind loading. However, in the case of a 1.8-meter diameter cylindrical shroud around a tower with wind blowing at between 10 to 40 meters per second, vortex shredding may play a role, which will cause vortex-induced vibrations. This is a complex phenomenon and extreme care must be taken. Near or at the natural oscillation frequency of the tower structure, this could result in the total destruction of the tower. None of the current options solves the problem of overstressed towers caused by wind loading. Through our collective experience in the military and aerospace industry, we introduce TowerWing, the only permanent solution to eliminate wind loading on towers. To illustrate the TowerWing solution, we will first remove all the load from the same 49-meter tower. As can be expected, the bare tower is no longer overloaded and stress on the tower is reduced to 42%. By installing the rotating TowerWing solution on the top section of the tower, the stress on the tower reduces to less than that of the bare tower. When the wing is installed on the populated tower, the stress on the tower is improved from 151% to around 38%. Key features of the TowerWing solution include immediate reduction of the wind loading on a populated tower to a lower level than that of a bare tower. Additional space for antennas becomes available on the tower at prime heights when the equipment is stalled behind the wing. This enables installation of new 5G antennas or lease to third-party providers. No interference with radio frequency signals transmitted by antennas. Scalable and modular solution that is easily adapted to accommodate specific tower configurations. Designed for ease of installation, the modular TowerWing design enables transportation to site without special vehicles and on-site assembly and installation using standard tower rope methodology. Access to the antennas and equipment on the tower is maintained. Maintenance can be performed while the wing is installed and operational, offering protection from the elements. Advanced monitoring systems enable remote observation of TowerWing performance. Optional camera sensors can assist with configuration management of the equipment installed on the tower inside the wing. Available for monopole, lattice and combination towers. Installing a TowerWing solution delivers many commercial benefits. Increased antenna capacity generates additional revenue. Newly designed towers incorporating the TowerWing will cost less. Increased income from existing infrastructure. Tower infrastructure will be compliant from a safety and regulatory perspective. Risk and insurance cost will reduce. Reduced operating cost as fewer inspections will be required. Additional revenue will result in a rapid return on investment. Adjacency business opportunities is created through advertising and branding. Calculated benefits of more than $120,000 per tower over a 5-year period. TowerWing. What if the impossible is possible? We are poised to make it happen. Join us today on this exciting journey.